Okay, so on the last lecture we discussed tissues, and that perfectly leads us into the integumentary system, which refers to your skin and all the accessory structures. And the skin and all the accessory structures are responsible for much more than just how you look on the outside. In the adult human body, the skin makes up about 16% of our body weight. In fact, the skin and accessory structures are the largest organ system in the human body. And as such, the skin protects your inner organs, and it is in need of daily care and protection to maintain its health. And so your integumentary system consists of your skin, your hair, your nails, and glands. They function to protect you from outside pathogens, helps with sensory reception, temperature regulation if you get too hot or too cold. Then also vitamin D production. So when the sun bounces off your skin, it helps your body produce vitamin D. Excretion, like if you get too warm, you'll sweat. And so there's a lot going on with the integumentary system other than just your skin. So when we're going to go ahead and look at the different layers of the skin, we can talk about the different functions of those layers. The top or outermost layer is known as the epidermis. This is going to be the most protective layer. It does not actually have any blood vessels, meaning it's avascular. Thus, the nutrients have to diffuse up from the lower layers into the epidermis in order to keep it alive. And so the epidermis is made of 4 or 5 layers of strata, with each layer having different cells that have changed as they move toward the surface. And so this is stratified squamous epithelia, different layers of epithelia of this epidermis. There are 2 major cell types that we can find in the epidermis, one being keratinocytes. This is going to provide tough, waterproof protein or keratin. And then melanocytes, which provide pigmentation for your skin. So you can think of melanin as the pigment aspect of your skin. And so what we can kind of see here with a close-up view of the epidermis is the top or outermost layer is dead or keratinized. And so this middle layer has keratinocytes that have melanin in them, and as they move toward the surface, they get smaller and smaller and just pack on top of each other and end up just being dead cellular material at the edge. And you can kind of see in the actual section of real skin cells, you can see this layer of dead epidermis at the top, and then a layer of living cells, and then the dermis underlies underneath. So at the bottom we have a basement membrane that everything is attached to. This is non-tissue. It's just going to be what's connected to connecting the epidermis to the dermis, where there actually is blood supply. So again, the epidermis is avascular, so all the nutrients that come into these cells comes from the dermis, the layer beneath the epidermis. You can think of epi as above or up. And so dermis, so it's above the dermis. There's also a hypodermis below the dermis. We'll get to that in a bit though. So then we have the dermal layer, the dermis. This lies between the epidermis and the hypodermis. This is primarily a dense connective tissue. It lies underneath the epidermis and above the hypodermis, hypo being below, epi being above. The dermis supports tissue. It's going to increase rigidity and strength of the skin. It has fibers that provide strength and elasticity for collagen and elastic. It has fibers that provide strength and elasticity like collagen and elastic, and these are going to help promote that structural integrity of the skin. And the dermal layer is the layer that when you get a tattoo, they have to breach through the epidermis and into the dermal layer so that they can make that a permanent ink. But if they go too deep and they get to the subcutaneous fat storages, the fat will absorb all the ink, so they have to be really careful when they're putting the needle in, that they only breach the top layer of the dermis so that that ink stays permanently. And so there are accessory structures associated with the dermis, and you can find hair, and that'll be the shaft above the skin surface. There'll be a follicle in there and a bulb. And then there's a smooth muscle called the erector pili muscle that attaches to the hair. I'll go back a slide here really quick. You can see the smooth erector pili muscle that attaches to the hair, and it helps erect or stand up the hairs, give you goosebumps. It raises those hairs in the upright position, possibly when you are cold, your skin will tighten up, and the rectus pilae muscle will raise the hair follicle up, or also when you're scared. You have sebaceous or oil glands that secrete sebum, and this is going to moisten and soften the skin, so it's providing a healthy oil to the skin. You also have sudoriferous or sweat glands. Again, they secrete sweat. You have two types, an apocrine or eccrine. Apocrine are going to be the actual odor that you get from it. So these are pheromones, and some people have really bad smelling body odor, but in general, we need an odor so that humans can recognize each other. And you might not think of it this way, but you do have an odor that is attractive. Everybody does. Females like the smell of men, and men like the smell of females. And so these pheromones are produced by these apocrine glands. And then we have eccrine glands that control internal temperature in response to thermal stress. So these are your sweat glands that are going to help thermoregulate you, or when you get too warm, they'll release sweat from your body to help cool you off. And then we have blood vessels in the dermis, and these are going to help supply nutrients, remove waste from the dermal layers, and then assist in temperature regulation. And then we also have sensory nerve endings. These are going to help us, again, with one of those main functions of the integumentary system in sensory reception, detect whether we're hot or if we're cold, whether we're being touched, whether we're moving, proprioception, deep pressure, these different Pacinian corpuscles, Meissner corpuscles, different sensory nerve endings to help tell us where we are in space and what we're touching or feeling. So then below the dermis, we have the hypodermis. It's also called the subcutaneous layer or superficial fascia. So you can kind of see those interchangeably, but this is the layer that's directly below the dermis, and it serves to connect the skin to the muscle layer beneath it. It's not actually a part of the skin, but it's just that connective tissue that lies below the dermis. So the hypodermis consists of really well vascularized, loose areolar tissue. And so this is a connective tissue, remember? And also there's adipose connective tissue down there. And these function for fat storage and provide insulation and cushioning for the integument. So for this reason, when we gain weight, it's in our hypodermis that gets thicker due to the abundance of adipose tissue down there. There's also different types of cells in your hypodermis, like fibroblasts and macrophages. And like I said, this can also be called the subcutaneous or superficial fascia. So now that we talked about the different layers of skin, we can talk about what happens to your skin if it's burned. And so there are 3 classifications of burns. There's actually a 4th one as well, but it's pretty similar to the 3rd one, and we'll just leave it to 3 for this class. And so the 1st degree burn is just the epidermis getting damaged. And the 1st degree burn is kind of like sunburn. And so the skin will be red, possibly swollen, potentially painful. This will typically heal within 2 or 3 days. 2nd degree burn, on the other hand, is going to be breaching through the epidermis and most of the dermis, the top layer of the dermis. So this will blister, and healing is typically going to take about 3 to 4 weeks. And then a 3rd degree burn breaches all of the dermis and the epidermis, all the way down to the underlying muscle almost. And so these dermal and epidermal layers are completely destroyed. All right, and so this will appear bright red or even black if it's charred enough. Healing cannot occur since the skin is completely destroyed, and so skin grafts are required, and major scarring will result. Skin grafts can be made from cells grown in a lab, so they'll be artificial, or even ones from cadavers or pigs can be used. And so the rule of 9s serves as a quick method of assessment for a medical provider to estimate the extent of a person's burn injuries. Burns are considered critical if over 25% of the body has 2nd degree burns, or over 10% of the body has 3rd degree burns, or if there are 3rd degree burns to both the hands, feet, or the face. And so if you look at these, they're all divisible by 9. So if the head and the front and the back of the head together are 9%, the chest and the belly are together 36%. So 18 and 18. Each arm is 4.5%, so each arm is 9% each, so 18% for the arms. The genitalia would be 1%, lower limbs 18% each, so 36%, and all of it making up 100%. And these percentages add up to determine how injured the person is for people in trauma, or like just for like a medical provider to determine the extent of one's injuries. And so after burns, we can talk about different clinical disorders of the skin. One of the more common ones that everybody, or most people, have dealt with at some point in their lives is acne or bacterial infections. And so acne comes to mind right away when I think of a clinical disorder of the skin. Like probably most visits in a dermatologist are either burn or acne related. And so many people struggle with this, and it's a skin disturbance that typically occurs on areas of the skin that are rich in sebaceous glands, so your sweat glands, so like your face and your back. And it's most common along with the onset of puberty due to associated hormonal changes going on in adolescence. So bed sores would be another form of clinical disorder of the skin. And so they're caused by constant long-term unrelieved pressure on certain body parts that are more bony, reducing blood flow to the area. And this ends up leading to necrosis or tissue death. So all the cells in that tissue are dying. Bed sores are most common in elderly patients who have debilitating conditions that cause them to not be able to move. Most hospitals and long-term care facilities have a practice of turning patients over every few hours to help prevent the occurrence of these bed sores, because if they're left untreated, they can be fatal if they become infected. Then we have cancer of the skin. And so basal cell carcinoma is named so because of the stratum basal layer of the epidermis that is affected by it. It's the most common form of skin cancer and accounts for more than 90% of skin cancers in the United States. And these cancers almost never metastasize or spread to other parts of the body. These types of carcinoma grow super slow, and they take months or even years to become sizable. Squamous cell carcinoma, on the other hand, is named so because it affects the keratinocytes of the squamous epithelium. It occurs roughly 1/4 as often as basal cell carcinoma. Light-colored skin and a history of sun exposure are even more important in predisposing to this kind of cancer than basal cell carcinoma. And men are going to be affected more than women typically. And unlike basal cell carcinoma, squamous cell carcinoma can metastasize and spread to other parts of the body. So it's definitely not something you want to be dealing with. And then we have melanoma, which occurs in melanocytes, or the pigment cells. And these become malignant. The chance of developing it increases with age, but this disease affects people of all ages. Many moles, like greater than 50, fair skin, and sun exposure are major risks. And then melanoma is the most deadly and fastest growing type of skin cancer. So from A to C is from not so bad to, oh, this is definitely something I don't want, to, wow, you really don't want that. So malignant melanoma is definitely the worst one here. And lastly, we can talk about how the body, or how the skin ages. And so as you get older, the amount of collagen and elastic fibers decreases in the integumentary system, and so the skin gets looser. This is why you have like wrinkles. You decrease the amount of fat in the hypodermis as well, and this is why thermal regulation is difficult in elderly people. The body is losing heat easier because there's less fat in the hypodermis. And then a decrease in sebaceous and sudoriferous gland activity leads to drier skin, and it's more difficult to maintain body temperature. And then also a decrease in melanin production. So as a result of these, the skin becomes wrinkled, drier, and thinner. And elderly patients need to be bathed less often and with the use of a milder soap due to the decrease in oil secretion by their glands. And so that wraps it up for the integumentary system. And we will go over these layers during lab as well.